In this example, we return to an example we've looked at before of this mechanism made up of links OA, AB, and BD. What we're asked to find here is that knowing the angular speed of link OA, we're asked to use the instant center approach to find the instant center for AB and then find the angular velocities for links AB and DB. So let's look at what we know. Link OA is pinned to ground at O. OA is rotating in a counterclockwise sense. And since OA is rotating about O, we can say that the velocity of the other end then must be perpendicular to the line connecting O and A, because O is effectively the instant center for OA. So we know both the magnitude and the direction for the velocity for A. If we now move over to link BD, we see that BD is pinned to ground at D. B, on the other end, its velocity must be along this line. It must be perpendicular to the line connecting it back to D. So although we don't know how fast it's going, we know at least the direction for the velocity of B. Well, the instant center approach says that if we then construct perpendiculars to the known directions of velocities for 2 points on link AB, so here if I construct a perpendicular to the velocity for A, that's this dashed line. If I construct a perpendicular to the velocity of B, that's this line here, that where those two lines intersect is going to be the instant center for AB. So these two intersect here at D. So point D is the instant center for AB. What that means is that at this instant, bar AB appears to be rotating about point D. Okay, so that's the qualitative nature. Now let's do the quantitative stuff. Let's start back at link OA. Since OA is rotating about O, we know the angular speed of OA. We can say that the speed of A is the length L times omega OA. Okay. Now if we consider A on link AB, it's rotating, AB is rotating about D, and with the way that A moves, then we conclude then that omega AB is rotating in a clockwise sense about D. In order to find that, we know that velocity of A, I'll say this is because what we know about link OA. And because A is on link AB and AB is rotating about D, we can say that the distance from A to D, that's L sine theta, times omega AB. So this is looking at link AB. Let me erase that and start over again and say that that's for link AB. So therefore, from this, we get that omega AB in magnitude is equal to the speed of A divided by L sine theta. And since VA is equal to L omega OA, this is the speed, rotational speed of link AB. And based on what we saw in the figure, that's in the clockwise sense. Now, B is also on link AB, and since AB is rotating about the instant center D, we can say that the velocity of B then is equal to the distance between BD, so I'll just write that as BD with the bar on top to represent that distance times omega AB, like that. So this distance between BD, what would that be? That's this length here is the hypotenuse, so that's L squared plus L sine theta squared, like this, square root. That's the length of this. So this is going to be equal to L times the square root of 1 plus sine squared theta. That's BD. Omega AB, we can cancel out the L's, and so that's omega OA divided by sine of theta. So that's VB. VB is going to be pointing this way, because we know from the start that it has to be along that line, and since it's rotating about D and AB, omega AB is a clockwise sense, that's the way that B moves. Therefore, we can say then that VB on, so this is because it's on link AB, VB is equal to this distance BD times omega BD. We'll say that omega BD, therefore, is equal to VB divided by this distance BD, like that. And therefore, that's also in the clockwise sense. Because if we look strictly now at link BD, if B is moving in this direction and it's rotating about D, then BD has to be clockwise. So we have all the numbers we need. We have omega AB, and from here we get omega BD. So the basic idea on the instant center approach is to find 2 points on the link for which you want the instant center, and these points you need to know the direction of the velocity. For AB, it works out that we know the magnitude and the direction for velocity of A. We know the direction for B, and drawing perpendiculars to those gave us the instant center of D for link AB. And then based on going through link by link, then we were able to pull off the angular speeds and the directions for the other 2 links, AB and BD.